So let's start with the previous year question paper. In a material has identical properties, elastic properties in all directions, it is said to be, options are homogeneous, elastic, isotropic, orthotropic. So as this material has elastic properties, so it should not be right options. So what is homogeneous, what is isotropic, and what is orthotropic? Let's find out. So homogeneous means same elastic properties at any point in a given directions. For example, wood means, let's take a body, same elastic properties means this is E1, here this E1, here E1. Same elastic properties at any point in a given directions means it should be E2 or E3, here E2, here E3. See, E2, E3. So what is here? In all directions, okay? Means it should not obey them. So homogeneous is not the correct answer. So let's go to the isotropic. Same elastic properties in any direction. In any direction, in all directions, it should be same. Let's take a body. Here E1, here E1, here E1, here E2, here E2, here E2, here E3, here E3, here E3. So answer is isotropic. Let's go to the orthotropic. Orthotropic means different properties in three mutually perpendicular directions. Means let's take a body. Here it is E1, here it is E2, here it is E3. And here also it is E1, E2, E3. E1, E2, E3. This is orthotropic. So we can know this homogeneous, isotropic and orthotropic. So let's go to the second question. If a composite bar of steel and copper is heated, the copper bar will be, let's take the copper bar and the steel bar. Let's put heat. If we heated the copper bar and the steel bar, both will be compressed. See, if you put the heat, then it will compress like this. So it will compression. The answer should be compression. Okay. Let's go to the third question. Maximum bending moment in a beam occurs where? Maximum bending moment in a beam occurs where? Options are deflection is 0, shear force is maximum, shear force is minimum, shear force changes sign. So the answer should be shear force changes sign. Every material obeys the Hooke's law within its, options are elastic limit, plastic limit, limit of proportionality, none of this. So this should be limit of proportionality. In a rectangular element subjected to like principal tensile stresses P1 and P2 in two mutually perpendicular directions x and y, the maximum shear stress would occur along the, options are plane normal to y-axis, plane normal to x-axis, plane at 45 degree and 135 to the y-axis, and plane at 45 to the y directions. So answer should be in a rectangular element subjected to like principal tensile stress P1 and P2 in two mutually perpendicular directions. Means here this P1, this is P2. X and Y. Here it is X and it is Y. The maximum shear stress would be occur along the plane. Here should be. This is Y axis, this is X axis. So it is 45, here it is 135 degree. So answer should be plane at 45 degree and 135 degree to the Y directions. Let's go to the 6th number. Principle of superposition is applicable when deflections are linear functions of applied forces. The action of applied forces will be affected by small deformations of the structures. Material obeys Hooke's law. None of this. So, the principle of superposition is applicable when deflections are linear functions of applied forces. Answer is A. Principal plane is defined as a plane on which the shear stress is. Principal plane is defined as a plane on which the shear force will be 0. Answer is C. 0. Poisson's ratio and is an Poisson's ratio involving elastic moduli. The shear force and bending moment is 0 at the free end of cantilever beam if it carries the shear force and bending moment is 0 at the free end. Free end means this is free end of a cantilever beam. If it carries point load at the free end, point load at the middle of its length, point load uniformly distributed load over the whole length, none of this. So as we know that this is cantilever beam, and if we put the point load here, then the shear force and the bending moment will be 0. And again, if we put the uniformly distributed load like this, 1, 2, then also the shear force and bending moment will be 0 at the free end of the cantilever beam. So answer should be 2, B and C. The shear stress on a beam section is maximum. The shear stress on a beam section is maximum on the extreme bottom surface fibers, on the extreme to top surface fibers, at the free edges, at the neutral axis of the section. So answer should be D, at the neutral axis of the section.